Okay, so today we're talking about one step. There is a way to do this. If you look on if you want to do the mole map thing, you can. It's not really the best way, in my opinion. It's more knowing the conversions, like we've been doing, is much better. So that's how I'm going to teach you today. Now, with that, you can see that we will be only doing either particles, like we've done before, or we will be doing volume. So with that, we know that we are always going to have 1 mole is equal to 6.02 times 10 to the 23rd. Particles, meaning either atoms or molecules, or we are going to be converting to the molar mass, which is something that you should go over in 10.5, which if you were in class you went over yesterday. And then you can do your same thing with liters. So 1 mole is always equal to 22.4 liters at standard temperature pressures, or stone temple pylons. Now, let's go with the first thing. It's kind of a little bit of a review. We went over a little bit on last Friday. Let's go over what we have. So now we know that we have dinitrogen pentoxide. We don't really have to worry about that because we're just going to molecules. So that means we're always going to be using that Avogadro's number. So we start with our 0.4 moles, and we're going to molecules. So we know that we have 6.02 times 10 to the 23rd. You can call it molecules if you want to, and then over 1 mole, so we can get rid of our moles. Now, when we do this, we can take our 0.4 and multiply that by our 6.02, because we don't have to worry about that times 10 to the 23rd. We can just keep that over here to the side, because really what we're saying is we're multiplying by 10 to the 0. So when we multiply, we always add our exponents. 23 plus 0 is 23. So when we look at our answer, we have 2.4, and we'll say 1 times 10 to the 3rd molecules of N2O5. Okay? Now, let's do one that is the other way too. So how many moles of magnesium is 3.01 times 10 to the 22nd atoms of magnesium? So what we'll do is we have 3.01 times 10 to the 22nd. Remember, you always start with your given. So in this case, we're going to moles. Remember, when we have moles, it's always going to be times 1. So that's the nice thing. It's always going to be 1 regardless of what we're looking at. So we have 6.02 times 10 to the 23rd atoms in 1 mole. So we can get rid of atoms. We can now take 3.01 times 10 to the 22nd and divide that by 6.02 times 10 to the 23rd. And we know that we're going to have to subtract these two and then just divide these two. So if we take 3.01 divided by 6.02, which should be 50, so we have our 0.5 times 10 to the minus 1, or we move it over and we have 5.0 times 10 to the negative 2, or you can just say 0.005 moles of magnesium. Okay, so that's how we find those. Now, for our volume, let's do the volume together. So what is the volume of 1.2 moles into water vapor, so H2O? As STP. Remember, 1 mole equals 22.4 liters of any liquid or gas. Well, gases can be considered a liquid. So in this case, we have to find our volume. So we're going to go to our liters over our 1 mole. We're going to get rid of that mole, and all we got to do is multiply. So we take our 1.2 times 22.4, maybe not the, and we get our 26.9 liters of H2O. Okay, now let's go with the opposite. So how many moles of argon are present in 11.2 liters? So we have our 11.2 liters. We're going to moles. We know we're going to divide that by our 22.4. And look at that. It's going to end up being the same thing as the last example on the last page. So that gives us 0.5 moles of argon. All right. Make sure you are always putting your correct unit and correct element or compound. All right. And that is all for today. And we'll do one mass next.